Hello learners! In this lecture, we will learn about software engineering. Software engineering is the science and the art of building system softwares that are number 1, on time, number 2, within budget, number 3, with an acceptable performance, number 4, and correct operation. The economies of all developed nations are dependent on software. More and more systems are software controlled. Software engineering is concerned with theories, methods, and tools for professional software development in the most cost-effective way possible. There are two types of software products. The first are generic products, also called off-the-shelf software. These are standalone systems which are produced and developed in an organization and sold on the open market to any customer. The second are customized products. These are systems that are commissioned by a specific customer and developed specifically for them. Let's now look at some attributes to measure effectivity of software production. These include things like number 1, maintainability, number 2, dependability, number 3, efficiency, number 4, usability. In the engineering process model, there are 6 steps. Number 1, specification. This sets out requirements and constraints on a system. Number 2, design. Here, the model of a system is produced. Number 3, manufacture. This is where the system is built. Number 4, testing. This is where a system is checked to see that it meets the required specifications. Number 5, installation. This is where a system is delivered to the customer and it's ensured that it's operational. Number 6, maintenance. This is where faults in the system are discovered and repaired. Software engineering, on the other hand, is slightly different from the engineering process model above. Software engineering, however, is slightly different from the engineering model above. Normally, specifications are incomplete. Secondly, there is a very blurred distinction between specification, design, and manufacture. Thirdly, there is no physical realization of the system for testing. And finally, software does not wear out. Therefore, maintenance does not mean component replacement. Let's look at some examples of generic software engineering process models. Number 1, the waterfall model. This has separate and distinct phases of requirement specifications and development, and these phases are iterative. One phase is carried out repetitively until it's free of errors. Then a second phase is started on. Number 2, the evolutionary model. Here, the requirement specification and development are intertwined. It is developed in steps, and when new specifications are added, the software again is enhanced or modified. Number 3, the formal transformation model. This is a mathematical system model and is formally transformed into an implemented system. Number 4, the reuse-based model. Here, the system being designed is assembled from already existing components. Thank you.